Hello my friends, and welcome to the seventh video, into which, my friends, we are going to carry on answering question number 7 in the past paper of Pearson Edexcel International GCSE, the year 2024, the 17th of May. And of course, my friends, we are going through the chemistry paper, and then we are going to start the English one. In question 7 here, my friends, a student uses this apparatus to investigate the rate of reaction between diluted sulfuric acid. So here we have diluted sulfuric acid, H2SO4. This is the sulfuric acid here. And excess means, here excess means we have extra amounts of zinc. So the zinc here is solid and it's in excess. Let's not forget this piece of information about zinc because it's very important. The reaction, as we see here, is Zn, which is an excess with H2SO4, produces hydrogen and zinc sulfate. Now, those are the steps. You can read them. You can pause the video and read them. I'm going to start answering the questions immediately. Name the suitable piece of apparatus to measure the volume of sulfuric acid. Generally, my friends, I have some important apparatus to use when we want to take a specific volume of a liquid. We have the measuring cylinder. I always advise my friends to use the measuring cylinder when the volume is more than 20, let's say 10 cubic centimeter. When the volume is more than 10 cubic centimeters, we use the measuring cylinder. And here we have how much? I guess 50. So I prefer to use the measuring cylinder. Can we use the pipette or a burette? Both of them are good. They can give us, let's say, precise volumes, but still we use a pipette or a burette when we want to take 10 cubic centimeters or less. So I prefer using the measuring cylinder. Second question here, my friends, is give a reason why the mass of zinc piece doesn't need to be measured accurately. Generally, my friends, when we have two reactants, we have two types of reactants. The first one is called the limiting reactant, which we need to consume all of it. The other one is the reactant which is in excess. In here, in the question itself, they say that the zinc is in excess, means we use extra amount of zinc, which is the in excess chemical material, to react with what? With the sulfuric acid, which is the limiting limiting reactant. Generally, my friends, in here, my friends, we want to make sure that all the amount of the sulfuric acid will react with what? React with the zinc. So that's why we add extra zinc, so that we neutralize or consume all of the acid. So why don't we need to measure the amount of zinc? Generally, because the zinc is in excess, and not HCl here, it should be H2SO4. We need to correct it. H2SO4 is the limiting reactant. That's why the mass of zinc is not important. We generally add an excess amount. Let's say, for example, for example that this 50 cubic centimeter of sulfuric acid needs, for example, 5 grams of zinc. If I add more, 6 grams, 7 grams, 8 grams, 1000 grams, they are the same, as long as 5 grams are enough to consume all of the H2SO4. So any extra amount I add more than 5 will be in excess. And as long as we have extra amount, or the zinc is in excess, the measuring the amount of or the mass of the zinc will be useless or irrelevant. So we don't need to know its mass accurately. Let's move to the third question. Give reason why student quickly connects the gas syringe in step 3. Generally, my friends, in here, the reaction between pieces of zinc, which is solid, and the liquid solution of dilute sulfuric acid will give or will emit the hydrogen gas. So the hydrogen gas will leave. So we need not to lose any amount of the gas, because we need to depend on the volume of the gas in order to know the concentration of the H2SO4 or the acid. So we need to be careful, and we need to connect the syringe immediately so that we don't lose any amount of the hydrogen, because losing hydrogen will give us false information about the concentration or the amount of sulfuric acid. So here, to prevent the loss of gas, the hydrogen gas. Let's move to the other page. Question number 4. State how the student would know when the reaction stops. Of course, as long as the reaction is taking place, zinc is reacting with the H2SO4. This hydrogen gas is being produced, and of course ZnSO4. The problem is that this chemical is colorless and we cannot notice it. Generally, zinc is in excess, so that we cannot observe whether it is disappearing or not, and H2SO4 is colorless too. So we will depend on the volume of the gas. As long as the reaction is taking place or the reaction is occurring, the hydrogen will keep leaving to the syringe, and it will push the syringe handle, this one, the syringe handle, or I don't know, it has a specific name, but I'll call it the syringe handle, let's say. So as long as the hydrogen is being released, it will have pressure. So it will push the handle backward to this direction. So when the volume here is written stops being increased, or when the gases stop being released, then the reaction is over. Here we have the volume of the gas stops increasing inside the syringe, no more bubbles. This is logical. And the plunger, yes, this is the handle or the plunger of the syringe, stops moving. Why? Because generally it was here. Then it started moving because of the hydrogen released from the reaction. When the reaction stops releasing hydrogen, the plunger here will stay as it is, and the volume here is going to stop increasing. Now, the next question, as we see here, my friends, the graph shows the volume of gas collected in the syringe during the experiment. We have here tangent to the curve has been drawn at the time of 80 seconds. Use the tangent to calculate the rate of reaction, R O R. Here you can go back to my classes and you understand what this terminology means. So here, use the tangent to calculate the rate of reaction. Generally, the gradient or the tangent or the slope can be calculated from 2 points. The first point and the second point. You choose any 2 points in this gradient. I chose 2, y2 minus y1 and x2 minus x1. I chose 2 points, m1, which is here when the time is 0 at the beginning of the reaction. This makes it easy for me because the x will be 0 here. And I found m2 here at 80, or not at 80, it's at 150. So it is 150 and the volume is 70. So I take y2, which is 70. This is y2, 70, minus y1, which is 20, as we see here, over x2, which is 150, minus x1, which is 0 here at the beginning of the reaction. And I take the result here. Generally, my friends, you can take, for example, a point here and a point here. You will have the same results, you will have the same answers. As long as the first one here is 0, then that will have a value, it will have a value here. And at the end of the day, the gradient or the slope is going to be constant from the beginning till the end of this diagram. Just now, my friends, let's continue here. This question, explain the shape of the graph in these regions from 0 to 60. Let's go back to this from 0 here to 60. This is the graph here. The graph here, as we see, my friends, is very steep. The rate of reaction is very ROR is very very high, the rate of reaction, because the chemicals are reacting very quickly. So here we have very steep slope, which is the steepest. And then from 60 to 150, from 60 here till 150 here. So the slope or the gradient becomes a little bit leveling off. Starts leveling off means start being the rate of reaction or the quickness of reaction start to be a little bit lower and lower, because when at the beginning, my friends, as you see here, the rate of reaction or the reaction, the velocity of reaction goes very fast, because the reactants here, they start reacting and they have high potentials. We have high concentrations of the reactants, so we have high potentials to collide to one another and react, while here we have some chemicals have reacted, and the concentration of the reactants has started to become lower. And as you see here, my friends, because of loss in the reactants, the concentration of reactants will be lower, so the collisions will have lower potentials to react, while in the third part here we see like the graph has become flat. This means that the reaction here stops or finishes, as you see, because we don't have any reactants to react. You may pause the video here, my friends, to read the information more academically. And question 8. Question 8, this question is about crude oil. Now, my friends, this is the end of question 7. The next video is going to be allocated for question 8. So till that time, see you and take care of yourselves.